Hi Math 95. In this video we're going to begin a new section, 11.2, where we continue to work with quadratic equations, but now we're going to learn a new way to solve quadratic equations. We can use the method we talked about in 11.1 where we were working with completing the square to come up with a new equation to solve any quadratic equation. Those that factor, those that don't, those that are pretty, those that are ugly, it doesn't really matter. We can use this new thing, this new technique on any quadratic equation. It's going to allow you to solve equations more quickly than completing the square, as you probably are experiencing. Completing the square takes you a little bit of time. When the quadratic is easy to factor, it kind of depends on whether this new technique will be faster or not. Factoring may actually be a faster technique still than making use of what we're going to do today in this video, which is the quadratic formula. This is a formula that you'll probably want to memorize. It's kind of complicated, but do your best at memorizing it. So let's take a look at what it looks like. The quadratic formula is a formula that gives you solutions to a quadratic equation in standard form. So remember that is ax squared plus bx plus c equals 0, a not equal to 0. And the quadratic formula looks something like this, right? This is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Right? To see how we actually come up with this formula, see page 576 of your textbook. It makes use of completing the square on this standard form of this quadratic equation. Okay, so just to give you a hint, the first thing you would want to do would be to move the c over, right? So you have the ax squared plus bx, and the next thing would be to get rid of that a living in front, because remember the completing the square, you have to work with just an x squared in front. Okay, but you can see exactly how this formula is arrived at on page 576 using completing the square. So let's do an example where we apply the quadratic formula. If you need to, pause the video for a moment and write down this formula because we're going to be using it in a second for our example. So let's use the quadratic formula to solve this quadratic equation we have here. X squared plus 8x plus 15 equals 0. First of all, what I'd like you to try to observe is if it is in fact factorable, first of all. So let's see if we have x squared plus 8x plus 15 equals 0. Can we factor this thing? Let's see, let's try x. Let's see, factors of 15, which could give 8. That would be 5 and 3, wouldn't it? 5 and 3, plus and plus. Same sign, both positive, yes. That in fact looks pretty good. So that means using the zero product property that I have x plus 5 equals 0 or x plus 3 equals 0. So that means we have x equals negative 5 or x equals negative 3. Okay, so first of all, notice that that was actually fairly quick, right? Factoring in this case probably would be the way to go, but just for example's sake, let's use the quadratic formula to see if we get the same answer. We will get the same answer. You should get the same answer, right? The processes will be equivalent. So what we first have to do to use the quadratic formula is notice, let's go back one slide here. Notice that x equals means that this is giving you these values of x. It's going to come up with these two values of x here. But how it does it is by making use of a, b, and c. And remember what a, b, and c are. They are what? The coefficients or the constant term from the quadratic equation, right? A is the number in front of x squared, b is the number in front of x, and c is the constant. So if you can identify what a, b, and c are in your quadratic equation, you just plug them into this formula and it'll spit out what the values of x are that will solve this equation. So let's go back to our example for a second. Notice that in our quadratic equation here, it's nicely bubbled here for us, right? There is a 1 living in front of the x squared, which means a is 1. There's an 8 living in front of the x, which means b is 8. And the constant term back here all by itself is 15, so c is 15. So let's try plugging them into the quadratic formula instead of doing this factorization like we did up here. So let's see, x equals, so I'm not going to go back a slide because I've got it memorized already, and hopefully you will soon too, but read along with me as I go ahead and plug in the values into the quadratic formula. So x equals, let's see, negative b plus or minus the square root of b squared minus 4a, which is 1, where's my pen, times c, which is 15. And let's extend our little radical a little further. There we go. All over 2a. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay, now let's go ahead and do some simplifying here. Negative 8 plus or minus. Notice the plus or minus here is giving us two answers, right? It's saying we'll have negative 8 plus what's under the radical, negative 8 minus what's under the radical. So in the end, we are going to get two answers. We'll just have to do some simplifying first. Okay, so this is 64 minus 4 times 15 is 60 all over 2. Let's keep going. X equals negative 8 plus or minus square root of 4 all over 2. So we're getting close here. X equals negative 8 plus or minus square root of 4 is 2. Notice we already have the plus or minus in front, right? Okay, all over 2. So that means that we have what? Remember, this means two answers right here. This plus or minus means we're really getting two answers. So we have x equals negative 8 plus 2 all over 2, which is what? Negative 6 over 2, which is negative 3. Hey, that looks familiar. Or, what else do we get? X equals negative 8 minus 2 all over 2. Sorry if that's too low, you can't see that maybe. That's over a 2, which is what? Negative 8 minus 2 is negative 10 all over 2 is negative 5. And those two things, notice, are exactly the same numbers we got up top when we just factored this thing, right? So this is sort of an example of when the factoring would have been probably faster and easier than using the quadratic formula, but notice it gives you the same answer. So if you just want to apply the quadratic formula every time, it's fail-safe. You're never going to go wrong doing that as long as you perform the simplification and the arithmetic correctly, right? That's usually where the trouble happens, is in the simplifying process. Okay, so let's try one more before we pause our process and keep the videos to be a little bit shorter. Let's try one more. So let's try this 2x squared equals negative 4x plus 5. Let me get a new sheet of paper. Okay, so let's solve 2x squared equals negative 4x plus 5. Okay, so first of all, notice that in order for this to look like a true quadratic equation in standard form, we have to rewrite it. It's not currently written in ax squared plus bx plus c equals 0, right? Because it's not equal to 0, first of all. So how do we do that? We add 4x to both sides to get 2x squared plus 4x equals 5. And then we have to subtract 5 from both sides, right? So really the quadratic equation we're working with is 2x squared plus 4x minus 5 equals 0. Okay, and this we could try to factor if we wanted to, but remember it gets kind of tricky when there's a number out front here, and we'd have to think about the combinations that would multiply to give me a 5 at the back and add to give me a 4 in the middle, or we could just quadratic formula it and we don't even have to think about the factorization. So notice here that this is telling us that a is 2, just like in our slide, and b is 4, right? A is 2, b is 4, and c, because it is minus 5, means that c is equal to negative 5. Okay, so now let's plug it into the quadratic formula. X equals, all right, so negative b, which is negative 4, plus or minus square root b squared minus 4ac, c is negative 5, negative 5. These are dots for multiplication, by the way. You can use parentheses over here if you want to imply the multiplication like this. That's totally fine. All over 2a. 2 from the formula, a, because a is 2. Okay, so let's see if we can simplify. X equals negative 4 plus or minus square root of, let's see, 16. What have we got? 4 times 2 times negative 5, which is 4 times 2 is 8. 8 times negative 5 is negative 40, but it's minus negative 40, which means that's plus 40. Yes, all over 2 times 2 is 4. So this is negative 4 plus or minus square root of 56 all over 4. And let's see if we can simplify a little bit, because I think, let's see, what have we got here? Factors of 56, 7 times 8, right? Which would mean, let's see, let's do our little tree. 8 times 7 is 56, right? And 8 has a 4 in it, 4 and a 2, right? So at the very least, there's a 4 living in there, right? So 4 times 14, right? Yes, is 56. So this is negative 4 plus or minus square root of 4 times 14 all over 4. And so this is negative 4 plus or minus, the 4 comes out as a 2 square root of 14 all over 4. This can be simplified a little bit because we're noticing there's like some 4's out front or something like this. It's not okay to just cancel the 4 and the 4 like that, right? We can't just cross those out because notice this 4 division right here says to do what? Divide the 4 into here as well as this entire thing, right? Yes? So what this really means is that we have x equals negative 4, the 4 wants to go into that too, plus or minus 2 square roots of 14 all over 4, right? This is just saying that I want to divide the 4 into each of the two terms, right? I'd say divide the 4 into the first term, divide the 4 into the second term, and now simplify. So negative 4 over 4 is negative 1. This now cancels like this, right? Yes, because now we're canceling the number out front of the radical. Plus or minus, let's see, we have square root of 14 over 2. Okay, and that's the solution to our quadratic equation. That would have been yucky to come up with for factoring, right? Yikes. Okay, so let's pause the video and then we will continue in our next one where we will work with some more quadratic formula stuff.